let's look at another example of using this technique we're busy talking about to evaluate the integral of a rational function. So in this case, we'll look at the integral of 8x squared minus 3x plus 9 divided by 2x squared plus 3 times 2x minus 3. Alright, so we'll notice, right, we'll look like this is our p, and that's our q. And then you'll notice that the degree of q is 3 and the degree of p is 2. And remember, if the degree of p is bigger or equal to the degree of q, then we first have to do long division. Right, so in this case, that's not necessary. So let's see. Well, the technique says that we look at the factors of q, we write down the decomposition. Right? So here we have two factors, right? Irreducible factors. Right? The first is this quadratic, 2x squared plus 3, right? And that gives us this term in the expression, or in the expansion for p over q. Right? And the other factor is this linear one, 2x minus 3, and that gives us this term. Right? So, as in the previous example, right, we start by adding these two fractions together again. So we have to write them, remember, over the same common denominator, which will be 2x squared plus 3 times 2x minus 3, so just q. Right. And so a, we're going to have to multiply by 2x squared plus 3, right? And this bx plus c, we'll have to multiply by 2x minus 3. That's the first step, and now we multiply out. And I'll say here, nothing happens, there's no multiplying out to do. But in the second one, second term, there we have to multiply out. So we get 2bx squared, right? Then we'll get 2cx, right? And we'll get minus 3bx, and we'll get minus 3c. Right? And again, remember, all over q. And now lastly, we group the like terms together. Right, so we look at the x squareds. Well, we have 2a and a 2b. Right, so we get 2a plus 2b x squareds. The x's, well, we have no a x's. We have a 2c and a minus 3b x, and the constants, well, we have a 3a and a minus 3c. All still over q of x. And now remember, because these two are equal, that means p, and I'm dividing by q here and by q there, means p has to be equal to this polynomial. Right. So that means that the coefficients for the x squared here, this polynomial, have to be the same as the coefficient for x squared in p. Similarly for x, right? The coefficient here for x must be the same as the coefficient for x there, and similarly for the constants. Right, so let's write down the equations. And so for x squared, we get 2a plus 2b is equal to 8. Right? And we can immediately see, well, we can divide by 2. Right? And we get a plus b equal to 4. Right? Second one, for x we have 2c minus 3b. And that has to be equal to minus 3. And lastly, we have 3a minus 3c. And that has to equal 9. Right, so in this case as well, we can divide by 3. So we get a minus c equals 3. Right. So let's see. Right, now remember, what we have to do here is find the numerical values for a, b, and c that satisfy all three equations at the same time. And so we do that by trying to eliminate the variables from the equations. And you see here we have an equation with a and b, c and b, and a and c. Right. So let's take equations 1 and 3 and we eliminate a from them. Right. Then we end up with an equation just involving b and c, which we can then combine with equation 2. Right, so let's say we look at equation 3 minus equation 1. Right, that'll get rid of the a's. Right, so equation 3 minus equation 1 is going to give you minus b minus c equals minus 1. Right. Or then b plus c equals 1. Well, let's see. So now we take this equation, let's call it equation 4, okay, and we combine it with equation 2. Right, so let's eliminate c, well, let's eliminate b from these two equations. Right, so we look at equation 2. Right, so that's 2c minus 3b equals minus 3. Right, and you add to that 3 times equation 4. Right, because that will give you minus 3b plus 3b. Right, that will eliminate b. Right, so what we're left with is equation 2 is 2c. Right, and here we'll get 3c. So we end up with 5c. Right, and here we'll have 3 minus 3 is 0. So c is 0. We can use that, and equation 4 then tells us that b is equal to 1. Right. And if b is equal to 1, right, then equation 1 tells us that a is equal to 3. Right, so there we have it, the values for a, b, and c. A is 3, b is 1, and c is 0. Right. So that means that we have p over q equals a, right, so a is 3, right, over 2x minus 3, right, now b is 1, and c is 0. Right, that's perfectly okay. Right, so we end up, right, so we can write integral p over q dx is an integral of 3 over 2x minus 3 plus x over 2x squared plus 3 dx. Right. And if we evaluate these integrals, right, we'll see this first one gives you 3 over 2 ln absolute value x plus 2 minus 3. And the second one, of course, gives you also, in this case, 1 over 4 ln absolute value 2x squared plus 3 plus a constant k. Right. And that's how it's done.